paper on enhanced peroxidation and cytokine dysregulation in HIV seropositive pregnant women with malaria co-infection in Nayut, Nnewi, Nigeria. Nayut is Nnamdi Azikiwe University Teaching Hospital. It's a tertiary healthcare hospital in Anambra State that covers Anambra State and other adjoining states. The synopsis: the study participants were HIV seropositive pregnant women that are 30, HIV seropositive pregnant women with malaria, and HIV seronegative pregnant women with malaria, and 30 control non-pregnant women. That is the setting. The groups were age matched. That is why we have the same number of participants in each group, age matched. Blood sample was collected from each participant for determination of malondialdehyde, oxidase, malondialdehyde, superoxide dismutase, selenium, zinc, tumor necrosis factor, alpha, and interferon gamma using standard routine method. The finding reveals significant oxidative stress and likely reduced immunity in HIV seropositive women with malaria co-infection. Malaria co-infection is a burden on HIV infection in pregnant women. This is actually what we observe. Previously in our center, we've been able to associate the burden of malaria on the HIV. We found out that people that have HIV in malaria endemic area, they have additional burden of malaria, and that affects the biochemical system and raises some complications in them. So based on this, we also wanted to look at what is the oxidative and inflammatory status of those pregnant women that are being treated, that are under ART, but that are also having malaria. Are they more prone, or are they susceptible to complications? So the study was designed to be a case control study, and a simple random technique was used to recruit the participants into the study. Blood sample was collected from the participants and used to determine the blood levels of malondialdehyde, with an index of oxidative stress, superoxide dismutase, with an antioxidant, selenium, with an antioxidant, zinc, antioxidant, then tumor necrosis factor, alpha, and interferon gamma as indexes for inflammation. So we broke the participants into 4 groups: the HIV seropositive pregnant women with malaria co-infection, 30, seropositive pregnant women without malaria, 30, pregnant women with malaria infection, and non-pregnant women without malaria that serve as a control. The study was carried out in the antenatal clinic of Nnamdi Azikiwe University Teaching Hospital in Anambra State, Southeast Nigeria, and laboratory analysis of cytokine oxidative stress markers was done at the chemical pathology laboratory of Nayut, while the zinc, the trace element, the zinc and selenium, were analyzed in a biotechnology research center in Awka. Then, for the analysis of HIV 1 and 2, we use national. Whether it is 1, we use a unit gold, we use stack pad, and we also use determine. For Plasmodium falciparum, we try to determine the parasite density. For the zinc and selenium, we use atomic absorption spectrophotometry. And for the malondialdehyde and superoxide dismutase, we use colorimetric method as described by the respective authors. In our findings, we found out that the BMI was not affected, but we found out that the diastolic was affected in those individuals. Then also, we found out that the inflammatory markers were significantly higher in those HIV seropositive pregnant women with malaria. unlike in other groups. There was evidence in other groups, but it was almost 80% rise in those with malaria. Then we also look at the index for the oxidative stress, the oxidants and the antioxidants. The malondialdehyde was also significantly higher in those pregnant women, HIV seropositive pregnant women with malaria. The same way superoxide dismutase, the same way the superoxide dismutase, but the trace element antioxidants, the zinc and selenium, were reduced in these categories of women, which means that HIV seropositive pregnant women with malaria may predispose to reduction in zinc and selenium level, which means that there might be either depletion of trace element antioxidants, or there may be a blockage of such assimilation. Then we also look at the parameters for inflammation. We look at their correlation, and we found out that there is some level of correlation between those parameters of index of oxidation. Now, what is our conclusion? Our conclusion was that oxidative stress and inflammation have a considerable influence on HIV disease progression, especially malaria endemic regions. Earlier, the burden of HIV malaria co-infection morbidity has been proposed in our earlier study. And in one of our earlier studies, we also determined that, we have also proposed that the secondary infection that is managed in HIV/AIDS patients is determinant on the endemicity of certain infectious or diseases within that locality. The evidence of significant oxidative stress in pregnant women presenting with both HIV and malaria comorbidity is indicative of likely health challenge such pregnant women are exposed to in malaria endemic area. As we can see, those HIV seropositive pregnant women with malaria, they seem to exhibit high level of inflammation. They seem to exhibit low level of trace element antioxidants, and they seem to exhibit high level of malondialdehyde. So, which is an indication that they are stronger stressors than when HIV exists alone in pregnant women, or when pregnant women does not have HIV and they even have malaria. So that level of interaction may predispose the pregnant women to danger in malaria endemic area. Then another thing there is that the significant interferon gamma and TNF alpha was indicative of potency of inflammation associated with the comorbidity, which was higher in comorbid state than in a single morbid state. Then this study concludes that the expression of significant oxidative stress marker and interferon gamma and TNF alpha may challenge Th1 response in pregnancy. And if Th1 response in pregnancy is challenged, that means that the fetus may be attacked. So in summary, we are saying that there should be additional care for pregnant women that are already having HIV in malaria endemic area. Should there be malaria, the complication might become much more severe. Thank you very much. These are the references I used. Thank you.
Thank you. Just one. Anyone have any question? Do you have any question? No question. Anyone Leplante or Xiao Chen? Do you have any questions for Onion? Leplante, Xiao Chen, are you online? Do you have any question?
No question. Thank you.
Yes, no question.
Okay. Here also we don't have any question. Thank you, Onion. Thanks for your nice presentation.
This is Chen Siyao, and I'm a Chinese student studying abroad in Japan, the Kyoto University. I'm now the doctoral degree, and very nice to see you guys. And my presentation is about this title, the bacterial detection using the dielectric forces assisted microfluidic LC oscillator array CMOS chip. I will tell you the background first. As you may know, it is during our food production routine, it is stipulated to have this food safety inspection before the selling, before the production before the product go to the market. And this food safety inspection relies on the traditional plate culture method. It takes 48 hours to cultivate the bacteria into colonies, and so that we can confirm their species and their concentration, so that we can assess the safety level of this food. But the problem is this process is time consuming. So it hinders the prompt action against the contamination and food poisoning issues. And that's resulting more than 3,000 food poisoning patients in Japan last year. And there's a need of to have an alternative bacterial detection technique that have these features: quick, low cost, and sensitive. And there shows some current commercialized equipment. They can achieve the quick detection of bacteria, like PCR, ELISA, multi-TOF. Yes, they are quick and very high sensitivity, but they all face the problem that these equipments are so sophisticated, so they are expensive and laborious intensive to be used. They need some pretreatment to be used for the food inspection. So basically, they are not suitable for the regular food inspection in the food industry. So most of them are used in the medical use. And here there's a trend of the biosensors. And while it is widely researched and different kind of biosensors for the bacterial detection have been reported, they can basically divide it into these 4 types. And those enzyme-based, aptamer-based, and antibody-based, they should coat this antibody onto the biosensor to help collect the bacteria from sample. They are high sensitivity, but they all have the shortage of the high cost and also the laborious pretreatment to coat this antibody. Well, comparing with them, the whole cells biosensor, it is low cost without pretreatment, but it is a lack of sensitivity. So there rises a strategy that we can combine this whole cells biosensor with another immobilization technique. Here I introduce you the dielectric forces technique. We can use this for collecting the bacteria near this whole cells biosensor and realize high sensitivity and low cost at the same time. And this is a hypothesis. And I will introduce you the dielectric forces technique. This DP is actually a phenomenon that it has been used for manipulating and separating cells in different research fields, and it's basically utilize the complex permittivity of those particles to realize the attracting or repelling of those particles. So it can be used for bacterial collection, and there are already some commercialized equipment that combine the dielectric forces with other detection technique to realize the bacterial detection. Like this example, combine the DP with the impedance analyzer. It uses the DP to repel the bacteria into the center of those sensing electrodes, and this impedance analyzer can sense the impedance change of those electrodes. And here shows another equipment. that utilize DP for the bacterial immobilization, and those captured bacterial can be numerated from the microscope. But above examples still utilize external equipment like the impedance analyzer and the microscope, so they are still still cumbersome. So our goal is to develop this kind of system that we use only one chip to realize all those things. So we have this sensor chip that incorporate the DP electrodes for collecting and LC oscillator for sensing of those bacteria, and they are designed out one sensor elements. And there are in this 3 millimeter area, there are more than 1,000 sensor elements. Each of these have these two functions. And there I will introduce you the simple mechanism. And this LC oscillator has a resonant frequency around 65 GHz, where it is sensitive to the bulk water. So when there's microbes exist near to the sensor, the bulk water here will be repelled and the volume of bulk water decrease. So the resonant frequency of this LC oscillator will change, and this will be output and confirmed. So we can use the DP for collecting bacteria and LC oscillator for sensing the collected bacteria. And this resonant frequency change, we call the frequency shift, should have the relation with the collected bacterial number. And this had been demonstrated to have a high sensitivity. So our goal is to develop a quick, low-cost, and sensitive bacterial detection technique based on this sensor chip, and to realize the non-colony microbiology detection for the food industry use. And here is the experiment method. We use the E. coli as a representative bacterial, and we will do the detection of this E. coli, and we prepare the experiments. Prepare the experiment sample by resuspend the original suspension into the designated KCl solution, and we adjust the bacterial concentration by the turbidity. And below here shows the experiment system. This is sensor chip. It is connected to the PC through this controller board, and their function generator is used to induce the alternating voltage. It is a power supply for the DEP components on sensor chip. And here we set a flow path onto sensor chip for the charging of the sample suspension. And this flow path has a special design of the narrow channel here, and we use from the channel from C to D. It's shown like this. And this is the experiment process. We use these areas for the experiments. First, we pump the bacteria through this channel, and we turn on the DP. And we divide this sensors area into two functions. One is the influx area, and the other is detection area. And I will show you the experiment process. First, we pump the bacteria and turn on the DP, so the bacteria will collect at the influx area first, and this bacterial concentration will be increased. And then we turn off once and turn on it again. So the enriched bacteria will be collected to the detection area, the thin channel area. And this part is for the detection use. And this strategy is supposed to increase the sensitivity performance of this sensor chip. And here shows the map. It is the result of the detection area sensor elements output. The bluish color represents more bacteria. It's captured on these sensor elements. And here shows the time series data. This shows the 0 times is when we turn on the DP for the second time. So in the detection era, those sensors output increase with the time. That is its accumulation of bacteria. And finally, after there is 10 minutes, we turn off the DP, and those collected bacteria are suddenly released. So the output dropped here. And here it shows only examples. And the result, the frequency shift result that related with bacterial number is derived here. It is a gap between the sample moment and reference moments. And so different bacterial concentration sample will have different frequency shift. And we conclude this data into this results graph. The x-axis is a different bacterial concentration in the food sample, in the sample, and the y-axis is the sensor's average output. And we can find they are basically positive correlated. And based on the calculation of the detection limits, the boundary is here, and it is estimated to have the detection limits of 2 times 10 to the power of 4 cells per milliliter. And in the food inspection standard, the dairy product have a food standard around 10 to the power of 4 bacteria per milliliter. So we can so these sensor chips, based on this experiment strategy, it has the possibility to realize bacterial inspection for the food, in the food, but the further improvement should be made to improve the robustness for the different food sample and make it not influenced by the residual or some ingredient of the food. That's all. Thank you for listening.
Thank you, Xiao. Thank you. Anyone have any question?
Okay, the presentation was good, but I saw a formula in the fifth slide that I did not understand how it's being used in this presentation.
Can you hear Xiao Chen?
Sorry, I cannot hear clearly.
Okay,
One more.
Closer, yeah.
Okay, I'm saying that I saw a formula in the fifth slide that I did not understand how it's being used. It's like a
Okay.
mathematical formula.
Okay, yes, thank you for your question. For this experiment, we use only the demonstration sample. That is not full sample. It is in the KCl solution. It is a buffer. Yes, we just pump this bacteria with a buffer into these flow paths, and use this PC. We can measure this each sensor element's output very quickly at almost real time, and we set the interval is 10 seconds for one measurement. So for each 10 seconds, we can get data of all those sensor elements output. That is result from the bacterial on those sensor elements. And so finally, we can we use DP to collect, and finally we can get this frequency shift that is relies on the collected bacterial number. Yes, and that's a principle to measure the bacteria in the sample.
Okay, just one last question.
Yes.
I see that you know this stuff very well. I just want to ask, have you ever worked in a company like this, or it's just that it's based on knowledge in school?
Oh, yes. It is actually during a bachelor course or some other school course, I cannot learn these things. I just start learning by getting to this project and using this sensor chip. It's from my supervisor and my my senior students. Yes.
Okay, thank you.
Thank you.
Any other question from anyone, Onion or?
I think somebody had to be unmuted. I don't know. Like I saw a mission, like to admit somebody to a company. I want somebody introduce.
You can connect.
Yeah.
So I may stop my sharing.
Yeah, you can stop and
Okay, thank you.
unshare your screen. Thank you very much.